Today's lesson, section 7.5b, we're talking about more trigonometric equations. We're going to do more of the problems where we have a number multiplied by a theta, but here we're going to look at the ones that we want to find all the solutions. Okay. So here I want to solve like I normally would, like we did in the last one, so I want to divide everything by 2. So I get cosine of 3 theta equals 1/2. Okay. And so here, if I have 1/2, think about where cosine for an angle gives me the ratio 1/2. That's in the first and in the fourth quadrants because it's positive ratio. So then that gives me the ratios of pi over 3, or the angle is pi over 3, and 5 pi over 3. But that'll be equal to 3 theta. Okay, and so then, since you're talking about cosine, it's 2 pi k plus 2 pi k for both. Alright, so then here I want to be able to get my theta by itself like we did in the previous problems. So I'm going to divide everything by 3. Know that for your fractions, it's the same thing as multiplying by a third. Okay, so then the 3's on the thetas cancel out, so you're left with pi over 9 plus 2 pi k over 3, and theta equals 5 pi over 9 plus 2 pi k over 3. Okay, and so these would be your solutions for this problem, because since we're not restricted by a certain domain or a certain range of values, interval of values, then I can get all of my solutions, and so the 2 pi k divided by 3 helps me be able to get all the iterations for each solution. Okay, let's move on to the next one. So here you have tangent of 3 theta plus 1 equals secant of 3 theta. Now, because of the two different trig ratios, there's nothing I can really do to help me get them into 1, really. So I can actually use a technique that we used before. If I squared both sides, that'll allow me to be able to insert a Pythagorean identity, because I know secant and tangent kind of correlate to each other in that sense. So if I square both sides, on the left I get tangent squared of 3 theta plus tangent of 3 theta plus tangent of 3 theta plus 1. That's multiplied all out. First, outside, inside, last. And then on the right, I get secant squared of 3 theta. Okay? So now I want to simplify, so I put my like terms together. So I get tangent of 3 theta plus 2 tangent, or sorry, I'm missing my square over here. So it's tangent squared of 3 theta plus 2 tangent of 3 theta plus 1 equals secant squared of 3 theta. Okay? Now I want to be able to insert a Pythagorean identity because I see secant squared 3 theta right there. And so that's the same thing as tangent squared 3 theta plus 1. So let's enter that in. So now I have the ability to put all my like terms together because everything's in the same, all the same terms are used. Now the nice thing with this problem is that the squares cancel each other out, so I don't have to worry about tangent squared or having to factor or anything. The ones actually cancel out, so all I'm left with is 2 tangent of 3 theta equals 0. And then I want to get tangent of 3 theta by itself, so I divide by 2. And so that leaves me with tangent of 3 theta equals 0. Okay, so where does tangent for an angle give me 0? Well, that would be at 0 pi, and also at pi. Okay, now since it's tangent, the period is pi, so then that's how often you're going to have an answer that repeats. So we put plus pi k for both. I want to get the theta by itself, so I want to divide everything by 3. So So those 3's reduce away, so it leaves me with pi, or theta is 0 pi plus pi divided by 3k, and theta is also equal to pi over 3 plus pi over 3 times k. Alright? Now, going back to that other previous example that we did in a previous video where we squared the cosine and the sine, remember that we had to check our answers because sometimes when we put in something that's not given to us, we might have extraneous solutions. So we need to check our solutions to see if they still work. So let's check our 0. So if theta is 0 pi, that means that when I plug it in, and remember to plug it into your original, not to the one that you squared, because obviously for the one that's squared it's going to work. So when I plug in 0 plus 1 secant of 0 times 3, okay? So then tangent of 3 times 0 is tangent of 0, plus 1, and I get secant of 0, okay? Tangent of 0, remember that point is 1 comma 0, so tangent would be 0 divided by 1, plus 1, and then secant would be the reciprocal of your cosine, so it would be 1 over 1. So 0 divided by 1 is 0 plus 1, and 1 divided by 1 is 1, so 1 plus 0 gives me 1, and that equals 1, so that one is a solution that actually works. Okay. Let's go try the next one. So if theta is pi divided by 3, if I plug that in, tangent of 3 times pi over 3 plus 1 equals secant of 3 times pi over 3. Okay. Here I can reduce, so it leaves me with tangent of pi plus 1 equals secant of pi. Now at pi you have the ratio, or the terminal point of -1, 0. So then for tangent it's still 0 divided by your cosine of -1 plus 1 equals, and secant is the reciprocal, so 1 over -1. So 0 divided by -1 is 0 plus 1, and 1 divided by -1 is -1, so then 0 plus 1 is 1, and then that gives me -1, so that one does not equal each other, so pi over 3 is not a solution. So none of those possibilities for every pi over 3 for pi over 3 would work ever. So the only one that would work is 0 and all of its coterminal points on the interval of pi over 3 times k. Right? Have fun. Here's a picture for your enjoyment. Have fun.